Hello. Hi, are you able to hear me? Great, great. All right, so looks like everybody is able to hear me. So, how are the exercises coming up? Do you have any doubts, or should we continue with our usual discussion? Okay. Hive or pig? Which one? I'm asking Nitika, like what kind of problem are you facing? What kind of error are you getting? All right, all right. Okay. So why don't you just drop me an email at Hadoop at No Big Data? Hadoop at No Big Data. Okay. And okay, if you have already sent an email, then I'll have a look at it. All right. Great. So, all right. Then any other doubts? If you have any questions before we start. No doubts? Correct. You have to submit those two assignments that we ended with. You have to submit those end to end. And so those two questions. So you can just send an email with your questions. All right. All right. Any other question? Anybody else? Abhishek, Harshal, Meenu, Pop, Sanjay. No doubts. All right. So do you hear any noise from my side, or is it clear? All right. All right. Okay. Just give me a second. All right. All right. So yeah. Okay, so till last Sunday, what we discussed was that because of the load, because of the velocity, we end up having lot of still I hear a lot of noise. So because of the load, because of the number of requests per second which your database receives, lot of uh, lot of things change with respect to database. You undid everything what you opted a database for. So all the features, the all the unnecessary features database is providing you, when it comes to the load, you actually drop all those features, including including the consistency, including the strong consistency. So that was the discussion, that was the RDBMS story we discussed last time. And Nitika, that will be impossible to start from starting of NoSQL. Okay, so that will be unfair to all other people also. So why don't you watch the video from the other session which I have provided, and that'll be better. So yeah, in summary, when there is a lot of load, when there is a lot of load, you basically realize that features provided by RDBMS are more or less useless to you. Okay, so that is when, and also last time whatever we discussed, our database, no matter what we did, no, still we were not able to cope up with the load. Okay, so the only way forward was to run the database parallelly on multiple machines and have 100% automatic failover. Okay, so that's where the NoSQL that's where the NoSQL starts, and that's where the whole phenomena of NoSQL started long back when Amazon felt a threat on say Christmas Day. Their servers got shut down and they could not cater to the traffic. What they realized was the existing database, the Oracle, what they were using for everything, was not sufficient. Was not sufficient for the kind of load they experience on Christmas or usually. So that's where they wrote a database called Dynamo, and they published a uh, paper on Dynamo, that how can such a data store be so helpful. And that's when the whole story of NoSQLs started. And as of today, we have really sophisticated NoSQL databases which run on multiple machines simultaneously. So almost all of the NoSQLs run on multiple machines simultaneously, and that's how NoSQL is defined. That's the single common characteristic which is very common and very unique to all NoSQLs. Alright? So now the next thing is, before we jump into NoSQL further, so far we discussed about CAP theorem, we discussed about what is a NoSQL in general, we also discussed about RDBMS story. I want to discuss something called a column-oriented database. Okay, a column-oriented database is characterized by how the data is physically stored. Okay, so in normal databases or normal data formats such as CSV, comma separated values, the data within a row stays together, stays closer to each other, while in case of In case of a column-oriented database, the data within a column stays together. All right. So we have this column, and imagine this table. The way it is stored in case of row oriented, the way it would be stored is 0, 10 Zoe, 12 Mary, 11 Kathy. 10 Joe, 12 Mary, 11 Kathy. This is how it is stored in case of row oriented. This 001 is the row number we have given. While in column oriented database, the data is stored vertically, as in 10, 12, 11, and then Joe, Mary, Kathy. This is how the data is going to be physically stored. Okay, when the data goes into the disk, this is how it is going to be. First 10, then 12, then 11, then Joe, then Mary, then Kathy. This is called a column oriented data store. Alright, so this is a very subtle difference between the two. Any doubts about this? Because this is generally confusing. People find it generally confusing. So is it clear to everyone? If you have doubt, I can clear now. Mhm. So when you are storing this table, this is a logical representation of the data. In physically, you will be storing it like a big array, right? One value will go first, then second value, the third, the fourth, right? So physically, either you can store like this, 10 Joe, then the first value will be 10, then Joe, then third value will be 12, and then Mary, then 11, then Kathy. That is called row oriented. We are considering rows and then we are moving into the columns. Correct? So that's what it is. 10 Joe, Mary, 10 Joe, 12 Mary, 11 Kathy. Correct? That is row oriented. Now if you start storing column values first and then you move in row, okay, that's called column oriented. So for the first column called A, we pick up all the values, say 10, 12, 11, and Joe, Mary, Kathy, and so on. Awesome. So there is a very good point. So Sanjay is saying, what advantage does column oriented database provide? So the good part about column oriented database is that first, generally, in a single column, all the values that go together are accessed together. Okay, and column oriented databases make it possible to split the data vertically. Okay, they make it possible to split the data accordingly. All right, so it's very arguable that it's very much arguable that whether column oriented is better than row oriented, but it's just one idea that some people found out that if we store column values together and compress them first, imagine that there is one column containing these the age of people, and now can somebody tell me what would be the range of those values? Anyone? If there is a column which stores age of the people, what would be the values in that column? From what value to what value? Hardly 0 to 100 or maybe 0 to 150, correct? Thank you, Sanjay. Now that means that if you take that column's data, then you can compress it better. Okay, you can compress it better. There are multiple compression algorithms that yield a really high compression. Okay, so because generally the way we look at a database table is that the whole column is dedicated to a particular value, and these values are very similar in nature, And therefore, when values are similar in nature, the compression works best. Correct? Is this statement clear? The When the values are similar in nature, the compressions are better. For example, for absolute layman, when you look at a song and a value or a lyric is repeating, you put dash 2 after this. Okay, say for example we are singing happy birthday, okay, and this is coming twice, so when you compress it, it quickly becomes dash 2. Correct? So that's how the most of the compression algorithms work, by minimizing the repetition. Right? So therefore, lots of researchers have found that if you store the values column wise, then the compression algorithm on all the column values work really, really well. All right? I hope that answers. So yes, you are right. Here the semicolon is the colon separate, the row separated, and comma is the values separated. All right. So it's just for representation purposes. Instead of choosing comma or semicolon, most of the databases choose invisible, non-printable character such as /0. Those kind of characters are chosen by most of the databases in order to avoid a conflict. Okay? So instead of choosing semicolon, because what if you have to store the semicolon itself? What if somebody's name contains semicolon? I don't know, but some African name might be containing a semicolon in the name. I have seen exclamation. Okay. So yeah, and so that's the benefit of column oriented. So is that was that clear, Sanjay? Was I able to make a point? All right. So that was the most important part which you need to keep in mind, that in a column, people found that in a column we generally store similar values, and if we take the all the values of a column and then compress it, then the compression algorithms give you far, far, far better results than row wise. All right. Now there is something called column for family oriented database. Today we are going to discuss HBase, and in HBase the important part you would notice is that it's neither row oriented nor column oriented, it's column family oriented, which means it's both. Okay, column family oriented means, so what is column family? Column family is a group of columns that first 5 columns belong to first column family, next 13 columns would belong to another column family, and so on. So you could, out of the whole table, you could say that these columns belong to first column family, these columns belong to second, and so on. All right. Now when we say column oriented database, means all the values inside a column family, all the values are first persisted. So imagine this, you have column family 1 containing 2 columns, employee ID and name, and second column family contains only 1 column. So all the values for these 2 columns will be stored first, and inside these 2 columns, inside this column family, the way the data will be stored would be row oriented. So 10 Joe, 12 Mary, 11 Kathy. This is how the data is going to be stored. Inside a column family, the data is stored as row oriented, while while once you have done with storing one column family, you move to another column family. Okay, so effectively what we have is we'll store 10 Joe first, then 12 Mary after, and then 11 Kathy after that. 10 Joe, 12 Mary, 11 Kathy, and after that we will store 23, 33, 45. Make sense to you? So column family oriented database provide you really brilliant way of organizing data. So if you create one column family per column, that means the data store is going to be purely uh, column oriented way, because say you have one column family for this, one column family for this, one column family for this. So first 10, 12, 11, then Joe, Mary, Kathy, and then 23, 33, 45. Okay. So if you have equal number of column families as columns, then it is more like a column oriented database. Now if you have a single column family for all the columns, then it is a row oriented storage. Correct? Because within a column family the way data is stored, so had it been all of these been in a single column family, we would be storing 10 Joe 23, 12 Mary 33, and so on. Correct. So basically the whole purpose of, you have got it correct, Harshal. The whole idea about column oriented, column family oriented is to make the data compact. Make the data compact and figure out, and when you store this data right in a distributed database, so since it is going to be stored on multiple computers, which means one part of the data could be in one computer while other part could be in another one. All right. Hello Tarak, and hello Sweta, I think you guys have just joined, and Amar and Malvika. All right, so that was our column family oriented database. Okay. So moving on, after that we have something called HBase. All right, that's what we are going to discuss today, and this is like a uh, very concise summary I could give you about HBase. So HBase is C and P in case of CAP theorem, which means consistent and partition tolerant. HBase is not has not tried to become highly available. Okay, you will understand why. And HBase is based on Google's Big Table. HBase is based on Google's Big Table, and after the Google's Big Table paper was published, the guys who were writing, who has written MapReduce and HDFS based on Google's papers, they also followed Big Table paper and then built HBase on the same line. And those who are wondering that about the new, the recently Google made their big table public. Okay, which means anybody can store data on Google's big table who has taken the who has purchased the services from Google. Now the important part is for HBase developers that the same API which is available for HBase can be used with Bigtable. Okay, so Google Bigtable provides supports the same API of HBase. Okay, and HBase is great for storing hundreds of millions or billions of rows. Okay, if you have below hundreds of millions of rows, If you have say 1 million rows, you should better stick to MySQL. It will give you better results. So HBase is strongly consistent. So HBase is strongly consistent. It's not eventually consistent. Okay, it's strongly consistent. Then there is something called automatic sharding. What does it mean by sharding? Sharding means dividing the data. If you have a huge data set, you might want to split some rows out of this big data onto one machine and other rows onto another. Like in olden times when there was no NoSQL, what we used to do is if you have got a big table, what we'll do is all the users for India, their data will be stored on one database. All the users from US, their data will be on another one, and the data of all other users will be on another database. So this is called sharding. Sharding means cutting the data and placing it on multiple machines. Okay. So instead of you manually sharding the data, manually dividing the data into chunks or into rows, say how out of 10 million, some few million went to one, few million went to another, and few million went to another database. So this is sharding. So you don't have to do the manual sharding in case of HBase. It has something called reason servers. So each machine which is running HBase is basically called region server. Similar, the concept is similar to data node. So each data node is basically called as region server. So HBase is made up of two kind of machines. One is HBase master, which is singular, and then there are something called region servers. Region servers are the data storage guys. Okay, and HBase master keeps a track of which row has gone where. Okay, which section of the data has gone where. So so the data get partitioned automatically and spreads across multiple region servers, and in case one region server is down, the other can take over automatically. There is a strong HDFS and Hadoop integration, which means HBase cannot run without HDFS and Hadoop. It's an integral part of Hadoop. Okay, it cannot run without HDFS and Hadoop, while HDFS and Hadoop can run without HBase. Okay, so if you do not have any plans to set up Hadoop, then you will not be able to use HBase. And also for massively parallel computing, you could utilize MapReduce on HBase. And HBase does not provide you any query language, and so for most of the querying purposes you will be using Hive. Okay, the only API provided by HBase is more like key value pairs. It's not like a full-fledged API the way JDBC or ODBC provides you. And the way we were running MapReduce on plain text file, similarly we can run the MapReduce on HBase tables, where each row is a record, and this record will pass to your mapper, and then it can do whatever it wants to do. All right. Now there are uh, because it does not provide you SQL kind of API or SQL kind of interface. It provides you a very simple get put kind of API, and this API is available as Thrift. Okay, and that means if you have written an API in Thrift, then almost every language is supported. Okay, almost every language you have supported. That's why most of these new generation components, they all have Thrift API. So if you want me to explain Thrift in detail, I can digress a bit. Okay. So whenever you are building a service or anything, you could choose SOAP, you could choose REST, or you could choose something like a Thrift. Correct? Now, so is everyone with me? So looks like nobody is with me. Okay. So only Abhishek is with me. All right. All right. So whenever you are building a API for your customer, whatever service you are providing, after a while your customer is going to come back and say that, hey, we are using say Ruby and we want the API to call your services in Ruby. Similarly, some other customer will come around and say, we are using Python. Can you give us a client which is in Python? The somebody else might come and say that we are using a web service, REST-based service. Can you provide an API there? So rather than trying to write your own clients in every language, you basically write your client in IDL. IDL, which means intermediate definition, interface definition language, or provided by Thrift. Okay, and hand it over to Thrift, and Thrift will generate all the APIs in around 50 languages. Okay, that means you wrote in one language and it basically generated the code for all, and effectively now you have the driver or API available for 50 different programming languages. That is why people code in Thrift. Okay, so in case you are also going for service layer, prefer Thrift over other. Thrift has come from Twitter and it's heavily optimized over other protocols. It is really, really fast. The data transport layer is really compressed, and the and therefore it takes a fraction of time to transmit the data as compared to XML. XML is heavily uh, you know it's XML is really heavy. It's heavy with respect to data. If you have 1 KB of XML, for the same thing there will be few bytes in the object format of Thrift. Okay. All right. So yeah. All right. So that's where you use Thrift. The other concept at HBase is coprocessors. Coprocessors are similar to stored procedures, and stored procedures are something that you store on the database side. It's a code or logic. It's a logic that is stored on the database side, and the stored procedure is executed when something happens. You can hook the stored procedure. Sorry, extremely sorry. So coprocessors are similar to triggers, database triggers. And what is a trigger? Trigger is a function, or trigger is a stored procedure which gets executed on various kinds of events, such as table got created, row got deleted, row got updated, or column got deleted, column got created, and so on. For lots of things, the trigger can get executed. You can hook the trigger to various events and that get executed. Similar is the idea about coprocessors. You create a function in Java and you hand it over to HBase and tell HBase that whenever a key of this name changes, then run this function before the change and run that function after the change. So those kind of hooks you can do using an idea called coprocessors. Coprocessors are great when it comes to providing security, sanitization check, or other kind of magic provided by HBase. Alright. Now there is something called Bloom filter also. Bloom filter we will discuss in detail after some time. Alright. Now Nitika is saying, can you repeat a region server? Region server is basically the server which will store the actual rows of the data. Okay. So the whole table will be divided into regions. Region is, anyway, don't worry, it will come again. We'll come to it again. Okay. So this is HBase's architecture. Yes, we will give you in the last slide of this session. I'll give you the detailed example of coprocessor, Tarak. And all right, so this is how the HBase architecture looks like. So you can see that the at the lower at the bottom you will see that there is HDFS and then there is a Zookeeper. Zookeeper you can think of right now like a service which helps in the coordination. Okay, you can think of Zookeeper like a policeman standing here, and this policeman is helping avoiding the deadlocks. Okay, now keeping Zookeeper aside right now, so we have HDFS, Zookeeper. On the top of it is the HBase. And what is it that HBase is comprised of? HBase is made up of something called a master. Master is just like your, how should I say? In HDFS, the way you have your node, what do you call it? The the what do you call it? The master in case of HDFS. Similar to that, we have HBase master, and similar to data node. So like name node, we have HBase master, and similar to data nodes, we have region servers. So HBase master runs on one machine, okay, and there are region servers which run on multiple machines, and region servers are the one which save the data in real, okay, and the data is stored in a format in a file called h file, and there are other nitty-gritties called write ahead log and other nitty-gritties. And on the top of all of this is HBase API. So when we try to use API, it is going to make a call to master and then is going to go to region server and update the data. All right. All right. So the other than the internals of HBase, what do we need to understand is how do we model our data? So the way when you must have studied the databases, you must have heard about various kinds of normalizations, creating foreign key primary key relationships, and converting your problem into table structure instead of instead of the tree structure of most of the data, you try to flatten it. That was data modeling with respect to relational databases. So HBase is only useful for structured data. That's correct. Any data store is helpful only if you have clearly figured out that this is where your data is, this is how your data is structured. But that does not mean that it will not store the binary data. So if you have figured out that these are the various fields, so in a video, say, imagine that there is a big zip file. This zip file contains 15, 20 portions of binaries, correct? Now you, instead of storing it as a single zip file, you want to store it in the database. So individual cell, not shell, individual cell in the HBase table can hold the binary data. Okay, can hold the binary data. So HBase is great if you have figured out what are the fields in your input data. Okay, if you haven't figured out the data, you would basically like to store the data in HDFS. Okay, that will be more useful to you. All right. So the same way we did the data modeling in 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 RDBMS, we also need to think a little bit more about the data modeling when it comes to NoSQL, and that's probably the most important part of this course, because you need to understand that what is it, how is it you need to think differently from RDBMS. Okay, so before going forward, and what does it data modeling actually means? On one hand, you know that our database provides these features. These are the features provided by our database. This feature, if we try to do this way, then it will be faster, and if we try to do this way, then it will be slower. If we want to store so much of other information, then it will be better. So that on one hand you have database features, that database restrictions or limitations. On one hand you have this, and other hand you have your business problem. And to take your business problem to fit into the features or limitations of the database is the role of data modeling. All right. So before we move forward, let's understand the data model provided by HBase. Okay. So So the first definition of data model as given by Google guys when they published this paper called Bigtable. If you have time, do go through this paper. It's actually very well written. Each word is so well written that you cannot remove a single word from the whole paper. Okay. Now look at this sentence. It says that a big table is a sparse distributed persistent multidimensional sorted map. Now, out of this sentence, you cannot remove even a single word. So, no single word is redundant in this sentence. At the same time, there is no need to add any more words to describe what is big table. So, similar is the HBase. So, HBase is sparse, distributed, persistent, multidimensional sorted map. So what does it mean by sparse? Sparse means your table will be very sparsely populated. So in first row maybe there is only one value saved, only in the first column. In the second row there is, in the third column the value exists, while rest of the cells are empty, and so on. So HBase does not mind sparse tables, while our relational databases used to bother a lot with respect to the sparse tables because they consume a lot of space anyway. Here it consumes no space if there is no value in a row. Okay, so effectively a big table or HBase is fairly sparse. Distributed. What does it mean by distributed? Distributed across multiple machines. Whenever we say keyword like distributed, it inherently means multiple machines. All right. Now, so if Nitika's question is, if there is no value, then consider it as a space. No. Space is a value. No value means no value. Then there is no storage consumed for storing that value. Okay. So it is sparse, then is distributed. Distributed means this. Okay, so the last one is map. Map is what? Key value pairs. So the whole big table is defined as if it's a big key value pair map. Okay. This map is not like MapReduce map. This map means like a dictionary, a big dictionary where there is a key and then there is a huge value. And that's how it is. So it's a big sparse one where some values might be there, some may not be there. It is distributed, the meaning the whole map is distributed across multiple machines. It is persistence, meaning that the map is stored onto the disk. There is no data loss if machines are shut down. Multidimensional means that it's not only a single key, we can also store composite keys. Okay? The key can be composite as well as value can be the full rows. Okay? Value can be a complex structure. So that's how we define that's how we define the big table. And one more keyword I forgot, sorted. Sorted means just like dictionary is sorted, although generally the most of the maps are not really sorted. You give them the key and give them the value, it will store. You ask for give them a key and it will give you the value. Okay, but dictionaries are sorted. Correct? So it's a sorted map. If you have located one key, you can iterate down and find other keys and get the values. Okay? So that's the benefit of having a sorted map. So these are the few keywords that define the data structure of of a big table or HBase. Now before we move forward, let me one by one describe the nomenclature. So first and foremost is HBase. HBase, sorry, first and foremost in HBase is the table. A table stores the data, and table is the biggest entity that contains data. Okay, so table is the largest entity that contains data. So for your project, you will have maybe one table. Okay, and table can contain anything, but table name has to be string. Okay, table name cannot be binary and cannot be something like exclamation or those something like slash. Those characters are not allowed in table names because table names are correspondingly created on the file system, and therefore table names have to be safe. Okay, tables contain rows, correct? Table contains rows, and a row is basically identified by a row key. This is something new. Please notice that generally in our usual databases, row does not need to have a primary key. But here it's very important to have the primary key. Just like a column has an identifier, a column has a unique name, row also has a unique name. So effectively in HBase, when you think about it, the there is no difference between the whatever we do for the column, we do for the row, and whatever we do for the row, we do for the column. All right. So row has a name, column has a name. All right. Row can be added, column can also be added in this in HBase as and when we want. Okay. Row keys do not have to be do not have a data type and are treated like a bit array. So row, and the interesting part which you might take a little bit of time to understand, that row key which we just told you, row key can be anything. It can be a binary data, it can be like a MP3 play music. Okay, so it can be a binary data, and almost everywhere in HBase, anything except for few things which I'll specify explicitly, like table name. Table name cannot be binary data, while column name and row name can be binary data. All right. Is table name case sensitive? The table name is not case sensitive. Sorry. Table names are case sensitive in the sense that uh, a table name with a capital name is different than the small name. Okay, and that's the way the whole HDFS is. Because at the end of day, corresponding to each table, it will be creating some folder, and that folder will be created in HDFS. So row key is same as row ID in SQL. It looks like that way. There are few differences. First, here having the row key is mandatory. In relational databases, it was not mandatory. Correct? Second difference you would notice is the the row key can be a binary data, while in case of our normal databases, row key could only be number. All right. So moving ahead, there is something. So column family, we gave you a little hint earlier by explaining column family oriented databases. So data within a row is grouped by column families, meaning multiple columns are grouped together into a column family. And column family impacts the physical arrangement of data. Okay, keep this in mind. So these points like column family impacts the physical arrangement of data basically tells you that if you have to access the data very frequently, say if you want to access my first name and last name together always, then keep my first name and last name in the same column family. Do not keep my first name in one column family and last name in some other column family, because first column family might be on first node, and second column family might be on other node. All right, the column families might exist on different nodes, while the data within a column family tends to be closer to each other. Okay, also important part, although we keep on saying that this does not require much of a structure, this is not very stringent about schema, but in case of HBase also, we have to create a table name upfront, and we also have to tell that these are my column family. But we don't have to define the columns upfront. Like we did in SQL, we do not have to define columns upfront, but we have to define column families upfront. Okay, so every row in the table will have same set of column family. Just like in our relational database, every row has same set of columns, same set of columns. Here it's the same set of column families. While every row can have different set of columns, but column families will be same for all. Though a row does not necessarily store data into all fields of a column. Okay, it does not need to necessarily add anything into a column family. It can very well leave everything empty. A row can be left completely empty as well. And column family, just like tables, column family's name should also be printable characters and should also be something with which you can create a folder in the file system. If you cannot create a file name or folder name with that column family name, then that's a invalid column family name and it will give an error. Okay, now moving ahead. Now comes something called a column. Column sounds like very familiar to all of us, but there are minor differences. First, so column exists inside column families. Okay, there has to be at least one column family in a in a table, and a column belongs to a single column family. Okay, same column name can be in two different column families. Also, the most important thing which will impact your decisions is you can keep on adding columns just like you can keep on adding rows. So in HBase, typically the HBase tables typically are also wide columns, meaning there are say a million columns in these tables. It is okay to have thousands of columns or 10,000s of columns or millions of columns in an HBase table. Okay? So the way we can keep on adding the rows, similarly we can keep on adding as many as columns as we want. Also, columns are not something we have defined at the top, which means columns are specific to the rows, which means first row can have 3 columns, second row can have 15 columns, third row can have 10,000 columns. It doesn't matter. All right? It doesn't matter. Is everyone with me? Doesn't it raise any doubts in your mind? Okay. Also, the name of the column or column qualifier can store a binary data, and you will wonder that what will I do with this binary data. So row key also stored as also utilized as the storage, column name is also utilized as storage, and the actual cell which stores the data is also can store binary data. Okay, and okay, so a cell basically is characterizes by first a table name. If you have to find a value, you need to know which table is it. Under the table, you need to know which row key is it. Okay, and under the row key, you need to know which column family is it. And once you know the column family, you need to know which column is it. Okay, and last one is which version it is. So each cell in the table has multiple versions. Okay, multiple versions are very important and they are very much utilized everywhere, specifically for maintaining consistency, for maintaining various kinds of data conflict issues. The versions of each cell comes as a very handy storage. Okay, so here is your timestamp or version. Okay, let me change it to version slash timestamp. So each value in the cell can have multiple values. Okay, cell can have multiple values, and these values are known as multiple versions of a cell. Now, by default in HBase, the the multiple versions are based on timestamp. Okay, the multiple version names are based on timestamp, but you can create your own version names for each value of the cell. All right. So if you do not specify any while reading a cell value, if you do not specify a version number, then it will give you the most latest value. If you do not specify any particular version while writing, it will basically basically take the timestamp as the version name. Okay, and the total number of versions by default is 3, but you can customize it per table. All right, you can customize it per table as per your requirement. If you do not want versioning in your table, you can turn it off. Now, here is the way it looks like. So you can see that in this there is a table called let's say we call it phone directory. Okay, this phone directory has got row keys. You can see 0001, 0002, and so on. Correct? That's a row key. And also we said sorted, which means row key, the whole table is always sorted by row keys. Row keys are sorted. Okay? The physical way, the data in the of row keys is always in an order. Next is the column family. So here there is a column family called personal. Then another column family is office. Under personal you have a column name called name. And under personal you have another column name called residence. Under column family office we have phone. And under column family office we have address. Alright. And under residence phone for row key 0001 there are multiple values, and the most recent value is the one which is highlighted. There are other values in the behind one. Okay, so this is how you can visualize your HBase table. Alright, these are all cells as marked by those rectangles. Like Rob is a cell value. Though this data looks pretty much like RDBMS, but the next example we are going to show after this is going to impact the way you generally design things. Now the same data can also be visualized like a hierarchy, that under a row key we have column families, office and personal. Under column family office we have one column, and under that column we have timestamp 1 and timestamp 2 and timestamp 3 and so on. Alright, so this is the physical view. This is how the data gets stored. I will show you physically also that how are tables being stored in HBase. Alright, so this is something I want to emphasize most out of the whole presentation. Alright, so this is the example quoted by Google people while giving the example of big table, and this is very important to understand. And stop me at every point when you do not understand anything. Okay, so this is the grand example which Google guys gave, and this is actually implemented in case of Google. So what does Google do generally? Google goes to people's website, goes to their home page. First it hits your home page, downloads your home page, find and saves it. Then it understands your page and then tries to figure out what all page does your main page link to. Then one by one it goes to those websites, those pages to which your page linked to, and keep on making a note of who is referring to who. Okay, who is referring to who, and based on who is referring to who, it keeps on giving them page rank. If more important page gives somebody vote, that page becomes more important, and so on. Just like our example of voting in the first one. Okay, when I say voting, linking a page linking to B, say your blog is linking to No Big Data, is actually voting to No Big Data internally. That's how Google interprets it. Google, basically the whole PageRank algorithm, the whole reason why Google exists today is because of its PageRank algorithm. And PageRank algorithms, the most differentiating factor or most basic premise was that it figured out which page is most important. It figured out which pages are most important, which pages are least important, and which user, sorry, which page is basically, and importance is decided based on who is referring to who. If A refers to B, that means B is more important than A, and if B refers to C, which means C is more important than B, and so on. So it keeps on going that way, and that's how it basically gives the result. It gives the result which have got higher page rank above than the one which has got lower page rank. Okay, so for computing all of this, it had to download the whole worldwide's data and also make a note of the relationships between various pages. And for that, they used the big table, and their big table was structured something like this. Okay, something like this. So this table is, let's say we call it the www corpus or www text, or the whole www data. Let's call it www data. From the World Wide Web, we have got this data. Now in this table, the row key is the URL, and URL will talk about why it has been written the reverse way. But for time being, you can just assume the row key for this table is the URL in inverse manner. So, so each row of this table contains the detail of a page. Okay, each row in this table contains the detail of the page, such as what are the HTML contents of this page. If it doesn't have HTML content, it might be having PDF, so there'll be another column called PDF, and in case it has MP3, then there'll be another column called MP3, and so on. Okay, then this row which basically stores the data belonging to one page will have other fields also. Fields such as who is referring to me, who is linking to this particular page, who is back referencing this particular page, and that will be mentioned here. An important part here is that as and when somebody as and when it discovers that a new website is referring to www.cnn.com, it will add a column into this table. Into this row, it will add one more column identifier. The way it has added one column identifier corresponding to cnnsi.com and mylook.ca. If you have a page which is referring to cnn.com it'll create a a column for your page also. Now, this is something which we never saw. Okay. So as and when we encounter a new page, we add one row here. And if we encounter a new page referring to an existing website, we add that as a column. So all the people who are hrefing to www.cnn.com, their entries will be separate columns in this row. Okay, the way we have cnsi.com, mylook.ca, there will be microsoft.com who is referring to cnn.com, and so on. All right, is this structure clear? No, I'm sure it's not clear. Feel free to. Uh, okay. So the way, so what we are trying to do, we are trying to basically for each page, let me, what can I do here? Yeah. So, all right. Let me just give it a thought. How can I represent this better? All right. So, yes. Let me just open a spreadsheet instead. What do you say? Instead of, because this will not do the justice. This will not do the justice. So there is a table like this, okay? And each row of this table, this is a row, contains multiple cells. This is not good. I'll do in a spreadsheet. Alright, so let's start with a very simple example. So, and the thing is, Google first visited a page called Microsoft.com. Okay? Microsoft.com. Microsoft.com contains, say, HTML, say, buy my stuff. Okay, I'm just oversimplifying it. So the HTML contains buy my stuff and so on. And the Microsoft.com's main page. Then it is having the href to say some research.ibm. Okay, is that good, Amar? ibm.com. Okay. So this was IBM's website containing buy my stuff as text and linking to this. Okay. So because this first website Microsoft first website Google is visiting, so all right, can I make it a little bigger? So we can think of it like this is a column family called content. Let me merge it, or let's start with a single one, contents. Okay, and we have got one row key. This is our row key, and the row key right now is Let's say Microsoft.com. Okay, for time being. So Microsoft.com is the row key, and the content is like this. Okay. So now a column family, the name of a column family can be null, and how do you so call this is contents is a column family, and contents column means the default one. And let me just copy this stuff. Okay, so cool. This is how we have stored it. All right, till now everybody is okay with this. So we crawled Microsoft.com. This is the stuff we found, right? Next thing we are going to do is we are going to go to research.ibm, and for research.ibm we'll go to their website. It'll have some more stuff, and we'll have, say, PDF paper. Okay, PDF paper as the default page. Okay, some binary data along with uh, some links to, say, HP. Okay, so some links to hp.com. And also note here, right now, here, okay. Now the moment we hit research.ibm.com, it is going to go create one row. That's correct. Now, whatever data it has discovered, we will create separate column for it. Okay, in the same column family called contents, and we call it a new name called PDF. All right, and so this is blank this time. And we also mentioned that the Microsoft was referring to you. Okay. Now instead of putting here, we say that referrer. Okay, referrer, and we give Microsoft.com in the column name itself. And with what name it was referring to IBM? As capital IBM. Okay, A href, and this was the name. Good. So this is how it is. Then next attempt would be, we'll go to IBM, sorry, HP, and it'll find some HTML containing a href to Microsoft.com. Okay, and we give it gives a name to Microsoft.com as Billgate, just for the heck of it. Now, the moment we hit this kind of information, it would try to store, okay, try to store referral being referred by hp.com, and here it will mention as Bill, not this, here, Bill Gates. All right, are you okay with me now? So as and when we are encountering more and more websites pointing to somebody, we are adding more and more columns. Similarly, as we are discovering new websites which we have not crawled so far, we are adding rows into the table. So you can see that as and when we are crawling more and more, the columns and the rows both keep on increasing equally. Are you comfortable? No. Ideally, this is not the the design we have done so far. Okay. Ideally, what we will do, we'll have say Microsoft.com is okay as an ID, but contents is one. Then another one we will have maybe content PDF, but this one we will not have this way. We will have separate table for this one containing who is referring to who, and we'll maintain the separate table. Okay. And when it comes to big data, joining separate tables, it becomes a very, very humongous job. And therefore, the intention always remains that we merge all the tables together into a single one. So is this diagram clear to you? So this diagram says that research.ibm.com is being referred by Microsoft.com as IBM. Microsoft.com is being referred by HP.com as Bill Gates, and so on. Similar is this diagram. Alright. Similar is this diagram. And these columns, right? These columns are not for everybody. These columns belong to each row. And because each row is more like a big hash table. Now there is one difference to the architecture. These are reversed. Why these are reversed? Suppose there is another URL called ibm.com. Okay? And if these are sorted, we told you, right? These things are sorted. That means H I J K L M N. So here it'll be like this and it'll be like this. Correct? First hp.com will come, then ibm.com, then microsoft.com will come, then research. But mostly what will happen is we are interested at looking at the data of ibm.com and microsoft research.ibm.com because they both belong to ibm.com. If we have to bring ibm.com and research.ibm.com together, we would like to do some tricky stuff, meaning we reverse it. Instead of saying ibm.com, if we say if we say okay, if we say things like HP, okay, and Microsoft, if we say reverse it, right? Alright, now you can see that if I sort this data, then IBM com.ibm and com.ibm.research will come together. Okay, because this whole table is going to be sorted by this name, correct? And therefore, to keep all the com.ibm and com.ibm.research together, we have done this magic, meaning research.ibm.com, xyz.ibm.com, or abc.ibm.com, all of those domains will come together in this table so that we don't have to search for it. Once we have reached ibm.com, we can just iteratively read rest of the data. Are you with me? Does that explain why the row key is reverse of URL? Awesome. Awesome. Okay. So this is a very good case study to keep in mind whenever you're designing the, because it took me quite a while. So when I was at, let's say, in Mobi, we were doing something on Cassandra after the recommender. We were doing something on Cassandra on high throughput systems, which they call now App Insights. So partial architecture was mine. So there there when we were dealing with Cassandra, that was my first time, and I have not used Cassandra that time. Then I went through these details and then realized that we could do a far better job. And then we did a redesign, and that redesign was something which led to really high throughput. Okay, because it took me a while to think like a NoSQL guy, meaning thinking that it's okay to add more and more and more and more columns. It's okay to have different number of columns in different rows, as well as exploiting the fact that the keys are sorted. All right. So everybody's okay with this example. Should I move on? All right. Also, here, as in when websites are being updated, we are creating their versions. Okay. Similarly, you can also utilize the versions for your own use case. All right. And all the attributes like who is referring to who and everything is also versioned. And this is what it'll look like. Alright, so to reiterate, the indexing is based on row key. That's the only index which HBase provides, which means the whole table is sorted by row key. Each region of the table, region is defined as sum of the continuous rows. Okay, rows. So if you have a big Excel, so this will be one region. Okay, and this will be say another region number 2, and this will be another region number 3. And you can see that whenever we define such kind of a region, it's basically saying that it starts at 17, goes up to 24. Okay, or we say up to 25. 25 is not included, which means it goes from 17 to 25. 17 is included, 25 is not included, which means there are 8 rows here. This is called a region. One region exists on one machine, other region might exist on different machines. So each region is defined as start key and end key. Everything in HBase tables is stored as byte. Okay? Everything, whether string, integer, boolean, everything is stored as byte, and you will have to cast it by yourself. Atomicity is guaranteed only at the row level. Okay, you cannot guarantee the multiple row transactions. Meaning, what does it mean by multiple row transactions? It means I made some changes in one row and made some changes in second row. What I want is that both the changes should either go together or do not go at all. What I do not want is that first change in the row has been successful, but second one has failed, and still first change still is being reflected in the table. That's what we do not want. If we want multiple row commits, multiple row transactions, then it is not possible to do so using HBase. All right. Column families have to be defined upfront. So here we define the column families as contents is a column family, anchor is a column family, and so those things we have to define upfront. In case you forgot to define, you will have to create a fresh table and then move data from one table to another. Okay? There could be any number of columns for each row, and columns can be created at runtime, and Column names itself can have data, and that too the binary data as byte array. And whenever we do an operation of retrieval from an H-base table, the data we get is ordered by row key, then column family name, then column qualifier, and then timestamp. Just that timestamp is the last ordering is based on timestamp in descending order, while rest of the columns are in ascending. All right. So, do you want to take a break? All right. Let's take 10 minutes break. Back by 10:11 p.m. IST. Make it 12. All right. Hello. So I'm back. Can you hear me? Hello. Yeah. Is it clear to you? All right. So Sweta's question is that in US there is a long weekend next week. So is it possible to schedule a class? That will be actually very difficult because we are already running really really late, and so if I take the break here, then it's going to basically postpone other following courses. So it's going to be difficult unless somebody else, or unless there is a mass bunk in the class. Okay. So, and all right. So yeah, Amar's question is that can you explain column family and column qualifier again? Column family is basically a group of columns, and column is just a column. Just that column family you have to define upfront while creating a table, while column qualifier or individual column you can keep on adding into a column family. All right. All right. So okay. So now we are going to discuss something called reasons. Tables are automatically partitioned horizontally into reasons, and so I will, how should I show you? Let me try to draw. Let me try to draw. I think I can draw it really nicely. So initially your table would look like this. Okay, and how should I cut it? Is there a way to cut it? All right. So okay, so I think I should try to. So initially your table will look like, say this is your one row. Okay, you added one more row, you added more and more rows. Okay, so initially it will be like this. The moment it reaches a certain threshold, it will be divided into two portions. Okay, two portions meaning two regions. These are region 1 and region 2. And here again we start adding more and more data. Okay, and here also will the parallelly the data will keep on adding on both sides based on row keys. Some of the row keys will go here, other will go here. Okay, it will be always a range. It will not be something like you know the single one. Okay, so automatically the each region defines a section of the data, and the range is based on row key. Row key from 1 to 10 goes in first section, and some 11 to this goes into and so something like that. All right, and as and when it keeps growing, and the moment, imagine that it has further grown really big, and say it is growing further, it'll again get divided into multiple portions. Okay, like this, or we can create multiple files. One is here, other is here. Okay, so this way it has created three regions. Region number one. Okay, this is region number one, this is region number two, and this is region number three. Okay, and as new data comes in, so data based on what is the row key, the data might go this side or data might go this side in this table. This is basically a table. I'm just trying to show it as a plain text, because okay, something of this sort. And if this keeps on growing big, it will be divided into half from middle, which means here, and there will be another reason. So right now we have four reasons: one, two, three, four, and so on. Okay. So these are regions. So tables are automatically partitioned horizontally into regions. Each region comprises a subset of table rows. A region is denoted by table it belongs to, and its first row inclusive and last row exclusive. Initially, table starts with a single region. As the data keeps on growing beyond a threshold, this threshold you can define. Well, if you go into Ambari, you can see that there is a threshold over there. As the region keeps growing beyond a certain size, the data is split into two halves, and so on. So as and when the data keeps on growing, automatically number of regions keeps on growing. All right? Everybody clear about the regions? Now, if you have a table in HBase, okay, let's try to do a little hands-on now rather than later. Okay, I'll try to do a little hands-on. Where is my hands-on? Yeah, here is the hands-on. So, yeah. So in HBase, I will show you the data that is stored. So the data is stored in this place. If you go into Hue, I'm not going into Hue, I'm trying to do it from the command line. Okay. Hadoop fs minus ls. Can see that. So here all of the tables of HBase are located here. Okay. So we'll show you how the tables are, but for time being, you can see that here on the top label is the table name, and then let's say Ambari smoke test. We say Hadoop fs slash Ambari smoke test. Under this there is a under this there is a the table name. After that, a reason number. This is the reason number. Right now there is only one region, therefore there is only one folder. And under this region, there are multiple column family. First column family, no, they're not this one. Yeah, there is only one family here, and recovery added. So there are, I think, two families. Okay. Under the column family is the store file. This is the actual file that contains the data. Okay. So you can basically say here minus cat, and it will be a binary data most likely. Right? Yeah, it's a binary data. So it contains some information. All right, so this is how physically the data is stored. So for each table, there is in HDFS, in this folder, it contains all of the data. At the top is your table name. Table name is a folder. Under that there is a reason folder. Under that there is a column family folder. Under that is the actual file. So now you can see that for each column family there is a single file. Correct? Which means, so for each column family there is a single file. For each reason, that means that the data inside a reason, inside a column family, is staying together. Alright? Again, the row updates are atomic. No matter how many columns you are changing in a single row transaction, all of them will happen or not happen, but there will be no intermediary stage. Either all of the changes in a single row will happen or no changes will happen. There will be no intermediate stage. Okay? Now, whenever we are querying HBase, we always create something like cursors. We call them scanners. And whenever we basically use them, we basically tell HBase that can you give me a scanner, and this is my criteria. A scanner criteria, scanner parameter could be the row at which we want to start the scan, row at which we want to stop the scan, row as in row key, okay, and the column, whatever columns we want it to return, and optionally we can also provide a small filter that can run on the server side. All right, filter as in something checking some value. Okay. Now, once a region server, so basically each scan will result in multiple rows. Okay, and those rows will be belonging. First set will belong to one region, and then for getting the data from other region servers, you'll have to do next. Okay, and so on. Now, the the other way to look at the architecture is this. There is master, there are region server 1, region server 2, and region server 3. Master is also storing data in HDFS. Region servers are also storing their data in HDFS. So master is storing data in HDFS, and region server is also storing data in HDFS, and which is fairly very clear. As I just showed you that you can actually go into this particular folder and check whatever tables have been created. So that's pretty clear that everything is stored in HDFS. Now, master and region servers, they generally communicate with each other using something called Zookeeper. We will discuss that after in the next session. Right now, you can think of Zookeeper as some service where master says to that service that if region servers are coming in, let me know. And all the region servers will go to Zookeeper and say, hey, I am in, inform master, and so on. So Zookeeper behaves like an intermediary. All right. The region servers, if you basically try to visualize the region server, this is how it will look like. So, for example, you have rows whose are starting from A and ending till Z. Okay. So, the first region might be from A to C. Second would be C to F, and third would be F to I, and fourth would be I to M, M to T, and T to Z. Okay, and each region server will be having multiple such regions, and these regions will keep on moving from one machine to another if one region server is going down. Okay, if any region server is going down, that particular region will be moved to another machine. Correct, correct. So inside each regions stay our region. Inside each region servers uh, are our regions. All right, let's have a quick look at HBase shell. So this is the HBase shell. We can say status. All right. So this looks a little cranky. I think it's just fitting here. All right, no worries. So is the font good? So let's say we are on HBase shell, and we say status. It says zero servers, average load. This is bad. Why does it say zero servers? Status. Ideally, it should say three region servers, two region servers, or something else. So all we will try to do is first we'll started the shell. We'll check the status, create a table with a column family, single column family with a name called myCF. Then we'll say list, and then we will again list. Then we'll try to add some values into this table. Okay, HBase. It says region servers all are dead. Alright, so there is one server available right now, and zero dead, and rest are coming up probably. Now three servers are up. Alright, now let's start with our. So this is little too much. Okay, so we create a table of our own. Okay, it says already existing, and we say to May. So we've just created a table called my table to May. It has got, we have to define some column family. It has got only one column family, and we can see by saying list. Okay, you can see there is a table here, correct? Next is that we can also look at the table using regex. Okay, we can say list dot star table. Now you can see that everyone uses regex. Also we say put my table. We are trying to put a value into this table with this row key into this particular column family with the column name 1, and our table name is to May, correct? Done. Now we can say scan my table, and note that we'll have to put a like this, and so now you can see that under here for row 1 we have got these columns, correct? Also, if you want to get the exact value, you can say whatever we have just added. So you can see that we just retrieve 1, 2, 3, 4. Alright. Also, you can have a look at describe my table or describe my table to May. You'll see that all the details about the table will be shown to you. Okay. Now, a few things to note. To delete a table, you can basically first say disable and then drop. Okay. Sorry. So if so it says that first you need to disable your table and then you can drop it. Why? Because when you disable the table, it basically disables all the readers. It will wait till the table is free, and the moment your table is free, it will delete. Then you can delete it. Correct. HBase shell will give you the shell prompt of HBase, and then you can start executing. What error are you getting? Get is same as find. Not really. In case of get, you have to basically specify the row key, and it'll give you. Okay. It's not an error. It's not an error. So this is what I'm also getting, right? This is exactly what I'm also getting. You should get a command prompt like this with 1.0 name. Nitika, it's not an error. All right. So that was how we can basically access the data in HBase, and it's basically get and put. If you see, it's get, put, and get. That's all. And there is one more extra called scan, and that's all. No questions? All right. Those who are little inclined towards Java, it looks horrible. The same thing what we did here, we are trying to do it in Java. It looks little more horrible than the command prompt. Reason being that in Java you generally have to write fairly big amount of code, and it's more flexible. Alright, so here you can see that we are first creating a config. Once we have created a config, we create an object called admin, which gives us the whole admin control of based on that config. Then we create a table descriptor, and on top of it we create a column descriptor along with a column family, and then we create a, a table based on this information. Alright, so table descriptor, we have added a family, we gave it a name, and then we created the table and with that family name. Alright, next is once you have done that, you can basically iterate over list of tables. You can see list of tables, and then we can report that the table has been found. Okay, or we can give an error, and afterwards we can basically access the data using our usual technique. So we define a row as byte array, we define the we define a put action, whatever we want to put the data, and then we can set that data into this. Basically we are saying p1 equals new put and this row. Okay, and then the table whatever we have created above, we can say table dot put, and our data gets added there. All right, so similar is the get is also very similar, so you can have a look at this API. Correct, table name is test, you're right. Okay, now if you have to write a map reduce onto the data onto an HBase table, it's not complicated. It's exactly the way we had done it earlier. We extend a mapper, we define the key and value, and then we write a map function, and then we write, the only difference is that by default you will get the input in the form of row as the as a record. You will always get a row as a record as the input, and you can output whatever you want to do. Okay, similarly we have reducer. In the reducer also we have the same mechanism. We extend a table reducer, and then you will get input as whatever key you had defined earlier. Based on that key, all the rows will come together, all the integers will come together, whatever we had done there, and then we have got the context, we can write the data into that, and so on. Okay, and the output of reducer will go into the output of the reducer will go into the HBase, not in HDFS, but all of that is customizable. So then we write a driver similar to what we had done earlier, and this driver basically writes the data into the runs your mapper reducer against the table, and whatever is the result of the reducer, it writes, it will be written into the into the HBase. All right. So here we are defining that we are initializing our mapper job. We are giving it a source table on which we need to run. In case we want to limit our limit it to only certain region, we can specify a scan area, and then we can define the mapper class and so on. All right. So other than the normal HBase is nothing but a big hash table where you keep on putting these key value pairs into various based on various criteria. Now, HBase provides you an interesting searching technique internally using a Bloom filter. HBase tries to make the search faster using a technique called Bloom filter. Okay? So whenever you're looking for row key, if row keys have become really high in number, it becomes very difficult for one single machine to handle all the row keys. Okay, it becomes very difficult for a single machine to handle all the row keys. All right. Therefore, therefore, HBase tries to delegate it using something called a Bloom filter. Okay. Now, a Bloom filter is an interesting idea. So you can always imagine that there was a watchman. There was a watchman whose role is to check the name of the guest in bunch of registers, and if the name of the guest is found in those registers, then it allows them to go inside. So this watchman is basically somebody who to who every guest that is coming, every guest that is coming, it asks this watchman again, watchman, and this watchman tells whether to go ahead or send this person back. So this watchman is generally overloaded, and because of the bottleneck, this watchman being a bottleneck, there is always a huge queue for the guests to go in. So, what do you do in this case? Can anybody suggest? So, there is a watchman in your organization which basically checks everybody's name against big register, and he is already pretty clever, meaning he has already sorted the names of the people and is using the best techniques possible. Now, what do you do in these scenarios? Is the problem statement clear? So the question is it any way possible to hire one more watchman to do the basic checks before the actual check is start? Is the problem statement clear to you? No? So there are two checks. Correct. So what we do is we basically create another rudimentary, kind of a very simple register which only contains first two letters of all the names of the people. Okay? So, okay. So out of say big register, we created a new register which only contains first in initials of all the people. Correct? And initials are going to be small register. Yes. So if somebody's initials matched into this first check, only then the actual check by the main watchman, only then the main watchman will work. Otherwise, this person will be returned from the new watchman itself. All right. For example, here this filter is what is we call as a Bloom filter. This new person who we hired, who we gave a list of only the initials to check instead of full name, because initials, how many initials, total number of, if there are if there are even if there are 100 million people in the registers, still initials will be how many total? If we are just picking up first two letters of all the names, how many maximum initials could there be? Anyone? We are taking first two characters. 26 into 26. That's correct. Okay. So that comes around to only 700 values. And that will work as a good filter. So 90% of the people will be returned by this simple rudimentary check, and only 10% of the people will go to the main lookup. This way we reduce the load of the main searcher by delegating it to a Bloom filter. Now, where is the catch? Where is the downside? Can somebody tell me what's the downside with it? No, it will not be 26 factorial, it will be 26 into 26. So, where is the downside of this approach? Is the approach clear? What we are doing? So first request goes to the filter, and filter is asked, do you have key 1? So the filter will say no. If filter says no, it means he definitely does not have. Okay? Because if so when we are taking the first two characters, so key one's first two character is KE, and it will match against KE, right? That if it is not found there, there is no chance that it exists in the main one also. Correct? But in case it is found, in case key 2 is found, the actual request goes to the main storage and then checked. Okay? Then then that one will decide whether it is there or not. So do you see a problem with this approach? Anybody? Do you see any downside? Or is this approach not clear to you? Bloom filter is very frequently asked in big data interviews for that matter. It's my favorite topic. Correct. Then it will check the whole list. That's correct, Tarak. So basically, in these two cases, these checks are redundant. So for this as well as for this, these checks are redundant. Alright? And that is the downside of this approach. Correct. So Tarak says that doesn't this? Yes, that's exactly what I mean. Tarak. Yeah, Nitika, that's correct. Alright, so basically it might seem that there are two checks happening for these two requests. First, second. First, second. There are two checks happening for these requests. But good news is that the probability or percentage of total such cases is really low. If you choose your function really well, if you choose your here we had chosen only first two letters. You could choose something interesting, something like sum of all the characters. Okay? Sum of all the characters, and then divided by 26, whatever is the denominator will become my Bloom filter. So you could do a lot of magic, and the if you are choosing a hash function, this is called hash function. If you're choosing this function really cleverly, the chance of false positives will go down. False positive is the last one. When the filter says yes, you can go, but the main system says no, you cannot go. Those are false positive. Correct. So basically, most of the cases, in the systems where most of the requests are coming for non-existent keys, the keys which do not exist in the system, if there are many such requests coming in, then Bloom filter really is useful. Is very useful. All right, all right. So okay, let me try to show you. Okay, let's say in our database there is Sandeep, there is Sanjeev, there is say Tarak, and there is say Abhishek and Nitika. All right. Now we decided that this is our main database. Okay, and let's just sort it for simplicity reasons. Now what we decided was we picked up first two letters of these, and I think I should also uh, so let's say we have Atikir and we have Abhinav. Alright? Now, if we just choose the first two letters of these, okay, we have these first two letters. Alright? So, let's say we are creating our Bloom filter based on this. Okay? And Bloom filter will have basically AB, NI, SA, and TH. Alright? This data is smaller than what we have there. Or even if we have Abhay, let's say Abha is also there. So still the Bloom filter will remain same. Okay. So when the user comes and asks for, is asking for, okay, Abhinay. User is asking for Abhinay. So what happens is the Bloom filter says yes. Okay. So the request goes to the main storage, and main storage, when it starts looking at it, it says no. Correct? Why did it say yes? Because first two letters are matching. So this is our Bloom filter, which is based on initials, because it is easier to check the based on initials and will be smaller generally. And this is our actual data. Okay. Here, if we have Sanjay, and we have others also here. Okay. So now you can see that the data will this Bloom filter code will remain really small. Now if somebody is looking for Zuri, the Bloom filter says no, and therefore the request does not go further. Okay. All right. So Tarak is saying, can there be another filter with the actual data sorted alphabetically So the search is reduced in the final. Of course, this final search is going to be anyway really, really fast. Okay? But when it comes to big data, the searching in the index itself, searching in the sorted data itself becomes humongously slow. Okay? So that's when these all techniques are devised. Okay? So everybody clear about them? About it? So this is called Bloom filter. Okay? Bloom filter is used at a number of places. It's used at really, really widely actually as of today. So there are a couple of more designs where you will see the bloom filter is really useful. All right. Okay. So that was bloom filter. We do not have to do anything about the bloom filter because bloom filter is by default enabled on Roki. And the only reason I have discussed bloom filter because as a concept it's quite powerful, and as a concept it makes it possible to delegate the search kind of a workload onto multiple machines. All right. All right, so we have coprocessors as well, as I was discussing. So sometimes you have to do things like before value being added to my table, please sanitize the values, check against these conditions. If these conditions are qualifying, only then you let the user save the data. Okay, so in those cases you define your coprocessor, and while defining your coprocessor you basically tell that your coprocessor is accessing extending the base coprocessor, and you are then you will implement pre or post kind of method, pre get, pre put, uh, pre table creation or whatever. There are so many methods that you can implement and then you can override them. Okay, so in case of a pre this and you say that the user is not allowed, you do not want the user to do this, you just throw an exception. All right. And same case you can do pre-delete, pre-put, post-put, and so much. All right. And there are two ways to basically implement and put it into production once you have compiled your code. One is you copy it to the region server. Okay. Second is add it to the HBase config. These are the two steps. First you copy it to the region server, then add it to the HBase config, which is here like this. But this would involve you, this would ask you to reboot HBase. Okay, which is not really feasible in the real time. So what you do is you can add this file as a you can add this class jar as a value in the table itself with a different column name, and then it will be considered as coprocessor. All right. So other than this, you can also access the HBase data using a REST interface such as this one. You can basically go to these URL and then access the data. All right. So you can see this. So we are starting the daemon. What happened to my daemon here? Yeah, let's start this way. This is better. HBase rest start at this port. So it'll start the whole HBase server with the REST interface as this port, and then you can access anything you want from the browser itself. Okay, it says not found. Oh, we had deleted those. The table is not found. What was the table name? All right. I think we deleted our table. All right. So never mind. So we will just find out other tables. All right. So we have my table, my table. Then we have, what do we have? Scan my table. There is no data. Oh, my table is disabled actually. Enable my table. Alright, so now if we say describe, alright, so you can see this. Let me just pick up something. And the column name is age. This is correct only, right? Row is this, column is CF2. Yeah, it has come. See the data. So it has given us the data. Now using REST interface, you can basically query anything the way we have just queried. Alright? Alright, so more about this syntax. It's a standard URL syntax. Like with every URL, it starts with scheme. Scheme could be HTTP, HTTPS, and then then colon, then double slash, user colon password, at the rate, the domain name, colon 8080, then the full path, and then the arguments. Okay. In the same manner, it tells you that what all can fit where. Okay, so you can have a look at this target further. Also, those who are looking forward to access HBase from JDBC, they can try a- Apache Phoenix, which basically lets you query the data using using JDBC onto the HBase. All right, is everybody okay with this? Okay, okay. So that's pretty much about HBase. If you have any questions, you can ask now. No questions? All right. All right. So we discussed a little bit about about Zookeeper, but we did not go into details. So we'll go a little bit more into details about our Zookeeper. All right. Should we start with the Zookeeper? All right. So all of you who have been doing programming or who know that there is something called multi-threading, right? So when you have a processor on your computer, lots of time it's free, okay? And say for example, it is while one process is reading data from the network, processor will be fairly free. It's not doing something else. So in all those cases, you would like to utilize threads such that one process is reading the data while one thread is reading the data while other thread is processing it, and that way both of these things could be done in parallel, because when it's reading the data, processor is not utilized. Processor is fairly processor is mainly free. Processor doesn't get involved in these in this network reading or writing the data. All right. So that's where the role of threads or parallelism comes into play. And if you have done a little bit of threads or parallel programming, you would have also known an idea about things like monitor, things like locking, things like atomic. So when there are multiple threads, to make them coordinate with each other, we create a lot of things, such as we create locks, we create monitors. There are a lot of syntax provided by the programming languages. But but that is no longer valid. All these locking, this, that does not make any sense if the program is running parallelly on multiple computers. Imagine this scenario. Imagine this scenario. We have multiple email processors reading the data, reading the emails from a single inbox and processing it. Okay, so for example, let's imagine that there is a service which indexes emails. And how does it work? It basically runs on multiple computers, okay, and connects to your POP3 server, downloads the data, creates the index, and pushes the data back into HDFS or somewhere else. Now, these email processors which are reading the data, how would you make sure that one email processor is only reading one email? Okay. Also, no two email processors are fighting over the same email. How would you ensure that? Anyone? Note that these email processors would be running separately on multiple machines. So what would you do? Anyone? Lock on email object. Okay. But locks are no longer valid when when the processes are running on multiple machines. Locks are only valid on the local machine. Correct? But the only thing is, if this POP3 server provided some kind of a locking mechanism, then your answer is very valid. If our POP3 provides something like setting a lock, setting a flag on the inbox, then it could have been great, right? What if it doesn't? All it does is each email has got a unique identifier which it provides. Other than that, it doesn't do anything. So this inbox is not providing you any kind of a flag or anything. It only provides you the unique ID for the email, and that's it. So anybody can suggest that? What will we do? Correct. Some master server coordinating this access. Good. Basically, we will create our own network file or some other service to which these email processors would be informing. Something like this. Okay. Email processors are reading the data, informing this. It's here. It has created, say, there is a MySQL server in which it has created a table called under process, in which each email processor keeps on adding the value and deleting the values from that table. That way, this particular database is acting like a coordinator. It's letting your email processors coordinate with each other. Alright? And that's exactly the role of Zookeeper. Zookeeper has been designed bottom up for exactly same purpose. So Zookeeper is nothing but a distributed coordination service. It exposes a simple set of primitives, very simple set of primitives like get and put. Okay? And it's very easy to program too. The way it provides you the data, it could have provided you get set straight away, but instead it has provided you like a file system, and you can create nodes and you can lock the nodes. Okay, so that's the data model it provides you. And also, Zookeeper should not suffer at all from race conditions and deadlocks. Okay, how many of you, does anybody know what is race condition? Nobody? Correct, correct. Thank you, Sweta. Thank you. So yes, everybody tries to compete with each other to access the same object, or more than one person is trying to access the same object, more than one person, and they're competing with each other. That's called race conditions. And race conditions at a lot of times result in a horrible uh, code. You know, race conditions are very difficult to find, very difficult to debug, and lot of programs which I have audited so far suffer from race conditions. Okay, almost every shell script suffers from race conditions. Okay, so Zookeeper, the way it has been designed is it should not suffer any race conditions. If there are two nodes coordinating with it, it should not be that it gets confused or the data gets corrupted. All right. So the design roles were very simple. First was the design role was it should be very simple. Second was highly replicated. I'll tell you this one. So the way the design had been that you so the users who want the coordination between its services, they will see Zookeeper as if it's a big file system, and they can coordinate with each other by writing into this file system. So the way people can look at Zookeeper is like it's a big whiteboard. If I have to say something to you, instead of telling it to you directly, you write it on the whiteboard. All right. So you can think of Zookeeper that way. It's a big whiteboard, okay, where we all people can keep on writing on it in order to communicate with whosoever they want. Okay. So so that there are multiple processes trying to communicate with others, it has created a hierarchical system like a file system. Okay. And the namespace has data nodes called Z node. Each node is called Z node. Just like we have folders in normal file system, folder contain files. Here it's only Z nodes. Z nodes are nodes which basically can have other Z nodes as children, as well as can have the data. Okay, a classic example of a tree. So each Z node has data, as well as each Z node has a parent, and each Z node can have children as well. Okay. High throughput, high performance, low latency numbers means really fast, and distributed as in runs on multiple machines. Highly available means there is no single point of failure, and strictly ordered access means synchronized. All right. It's highly available or replicated means that there is no single point of failure. And how does it do that? So, okay. So the client keeps a TCP connection. It keeps on getting various kinds of events from the server from Zookeeper, and client keeps on informing the server that I am still connected. I have not got disconnected and there is no problem. So client keeps on telling Zookeeper that I am here by the way of heartbeats. That way Zookeeper knows that the client is connected. Zookeeper knows that this guy is still awake. Alright? If the connection or the network connection drops, the heartbeats will stop and Zookeeper will immediately figure out that this particular node is down. Also, in case of Zookeeper itself, what we are trying to explain here is Zookeeper itself is multiple machines. It's not a single machine. Okay? So all of these servers which make the Zookeeper, they know each other. They basically keep in memory image of the state and transaction, and snapshots are stored in the disk. Okay, all right. So next was ordered, which means synchronized. So Zookeeper, as and when you are making any change like creating a node or updating a node, every change has got a number. And this number is something which makes it possible, to have the synchronization in place. Okay? And it's very really fast. Okay, so then whenever somebody defines you a product which is like really rock star, you should always ask then what is the downside. Okay, so this one is heavily consistent, meaning synchronized, and does not suffer from data locks, as well as it's super fast. Then why don't we use it for everything? Why don't we use Zookeeper for everything? Reason being, Zookeeper has been designed for small data. Small data as in Zookeeper Z nodes, all the Z nodes can store data in few hundred kilobytes. It cannot go beyond that. If it tries to go beyond that, then the whole objective of having Zookeeper is lost. Okay? So, alright, so it provides you a quick interface to check whether the server is up or not. Okay, you can either say telnet and can say localhost 2181. Okay, and you can say are you okay. It says I am okay, which means Zookeeper is running. Also you can say things like conf, and it'll give you the details about the config here itself. Alright, so these are the 4-letter commands which help you in checking the status of the Zookeeper. So this one, the are you okay kind of commands are running on 2181 port. You can connect to it. So here I'm saying telnet localhost, meaning connect to the localhost at this particular socket or the port, and there we are now connected. We can say are you okay, and it returns that saying I am okay. All right. Installing Zookeeper is easy on one node, but if you have to install on multiple node, it will take a significant amount of effort. Alright, so the data model looks like this. So it looks like a file system, and so I'll show you that file system. So we can say Zookeeper client. Now I'm connected. I can say ls. I can say ls slash. So it shows that at the top level, these are the Z nodes created. Under Fab 28, what do we have? So under Fab 28, these are the nodes. Okay? And we can further say, alright? So we have got these, and alright? There is nothing in this. We can also say get, and it will give you the value with respect to this node, and the value is SUBSE. Okay, so this is basically a list of all the Z nodes. Okay, and it looks like file system, but it's not really like a normal file system, because node can have data as well as can have further nodes. All right. So we'll continue this discussion tomorrow. I think all of you have also got really, really tired. Are you there? All right, then we will continue this discussion tomorrow from here. And till then, please go through HBase and try to finish it. Finish that exercise. I have missed to explain to you there was supposed to be a one problem. Okay, just a second. Hold on with me. And I think, yeah, my. All right, so we have here, yeah. So here the question which you have to attempt is this. If you have to design a simple Gmail like email storage, I'm not asking here to design the user interface. All I'm asking that if you have to have this Gmail kind of a storage where it will store everything, then what kind of a data model needs to be there in HBase? Okay, so please attempt this question. All right, please attempt this question. Okay, then have a good day. See you. Bye bye. Thank you, Pop. Thank you, Amar. Thank you, Sweta. Thank you, Minu.